Hi everybody, thanks for joining my talk. My name's Audrey Long, and today I'm going to be talking about threat modeling fundamentals with a Star Wars twist. Before we get started, here's a little bit about me. So I have my master's degree in cybersecurity from the Johns Hopkins University. I got my bachelor's degree in computer science from the University of Cincinnati. And currently I'm a security software engineer at Microsoft. I love to travel, to cook, and to build things. And here you can see some of my favorite nerdy things, including some of my favorite games and my favorite book series. Today, we're going to be having our deep dive session over the wonderful world of threat modeling. We will leave today's talk with new perspectives and learning. By the end of this session, we will obtain a security mindset, gain threat modeling fundamentals, walk through the steps to generate threat models, and we're going to have a fun exercise where we will threat model the Death Star and gain some nerdy knowledge along the way. So before we get into it, what is threat modeling? So threat modeling works to identify, communicate, and understand threats and mitigations within the context of protecting something of value. A threat model is a structured representation of all the information that affects the security of an application or a system. In essence, it is the view of the system and its environment through the lens of security. Threat modeling can be applied to a wide range of things, including software applications, systems, networks, distributed systems, IoT devices, and business procedures. Really anything. So who should be threat modeling? Software engineers, security engineers, architects, program and technical program managers, software testers, really anyone with a working knowledge of the system and basic understanding of security can do threat modeling activities. So when should we use threat modeling? It's best performed these during design sessions, because that's when it's the easiest to make changes. It's also less costly than adding mitigations and testing them after your solution has already been implemented. Using threat models whenever you design new systems or updating existing ones. Some examples for this include creating a new Azure microservice or cloud application, designing a public API to provide customers access to your data, adding a new feature to an existing application, creating a new cloud infrastructure project, or really creating any type of software. So security requires a particular mindset. Good security professionals see the world differently. We can't walk into a store without noticing how to shoplift. We can't use a computer without wondering about the security vulnerabilities. And we can't vote without trying to figure out how to vote twice. We just can't help it. This kind of thinking is not natural for most people. It's not natural for engineers. Good engineering involves thinking about how things can be made to work. The security mindset involves thinking about how things can be made to fail. It involves thinking like an attacker, an adversary, or a criminal. You don't have to exploit the vulnerabilities you find, but if you don't see the world that way, you'll never notice most security problems. By adopting a security mindset, you emphasize the attacker, their motives, means, and all the ways they can wreak havoc in your system. This approach looks at entry points and system weaknesses and allows you to focus on critical assets holding highly confidential data for your system. When weaknesses are discovered, emphasis is placed on protecting those assets instead of the entire system. Here you can see the core algorithm for developing threat models. Within the commercial industry, this is a condensed version of a classical model. However, anything can be used from either approach when creating these threat models. And you should consider how to create a threat model based on your system and the requirements that you need to meet. However, here is a really simple implementation of how to create a threat model, and this is how I create threat models in my day-to-day job. Basically, we need to analyze the existing system, design data flow diagrams, identify the threats, brainstorm some mitigation strategies, and continuously iterate and verify these threat models. So, analyzing the existing system. This is the design phase, and it's the starting ground for your threat modeling activities. You'll gather as much data as possible about what you're building, what you're using to build it with. And some of the key goals here are to develop a clear picture of how your system nominally functions, enumerate services consumed by your system, investigate environmental assumptions and security controls, gather system requirement documentation, and identify some of those key security stakeholders in your project. The second phase is creating the data flow diagrams. DFDs are a visual representation of any process or system flow of information. By mapping out your process or system's flow of data, DFDs help you better understand your process or system, uncover its kinks, improve it, and can help you implement a new process or system. Some of the key goals here are to understand the user and system scenarios throughout the system, establish trust zones and boundaries within your system, identify user permissions throughout the system lifecycle, and investigate protocols being used inside and outside of the system that's being designed. Data flow diagrams are made up of shapes that create graphical representations of your system. Each shape represents a unique function, and each interaction is analyzed to help you identify potential threats. Using shapes correctly helps you receive better input from colleagues and security teams. Everyone will then understand how the system works, and it can also help everyone avoid going through countless design documents and development plans to get them up and running. In this phase, we're going to identify the threats. We're going to use the data flow diagram to find potential threats against your system. We will use a threat modeling framework to help you find the most common threats and ways to protect against them. A threat modeling framework is essentially a series of rules and guidance associated around testing out threats within a system or an environment. Threat modeling is a great technique to help you find issues early into the development cycle. Choosing the right focused approach helps you tailor the threat modeling exercise. You'll find more actionable items and ways to solve them. Microsoft traditionally uses STRIDE, an acronym for the 6 main threat categories, to provide an extensive but not exhaustive list of threats. So here are some common threat modeling frameworks. So STRIDE is a threat modeling framework developed by Microsoft employees and published in 1999. The STRIDE threat modeling framework is focused on the potential impacts of different threats to a system. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privileges. By considering these potential impacts or goals and considering how they can be achieved, it is possible to identify attack vectors for the system under test. Based on this information, it's possible to assess the risk and impact of each potential threat and develop countermeasures to mitigate against it. MITRE ATT&CK Framework is a federally funded research and development center of the U.S. government. One of its main areas of research is cybersecurity, and the MITRE ATT&CK Framework and related SHIELD framework is one of the products of this cybersecurity research. MITRE ATT&CK is designed to support cybersecurity by providing a framework for threat modeling, pen testing, defensive development, and similar cybersecurity exercises. MITRE ATT&CK breaks the life cycle of a cyber attack into 14 stages called tactics. And each of these tactics describes a specific goal an attacker might need to achieve on their way to overall objective, such as escalating privileges or gaining access to account credentials. The OWASP Top 10 list is one of the most famous products of the Open Web Application Project, OWASP. As the name suggests, it focuses on the list of top 10 web application vulnerabilities. The OWASP Top 10 list is a great starting point for performing a threat modeling exercise for web applications. It outlines the most common vulnerabilities in web applications, and due to its high visibility, also the starting point for many cybercriminals. Now, let's talk about brainstorming mitigation strategies, phase 4. This phase is where the fate of all threats is decided. Each threat modeling framework threat should map to security controls from your environment, which offer different functions and types to choose from. Once the mitigation candidates are created, assigning a criticality or weight to each one to determine which mitigations need to be implemented right away along with the complexity and time to fix each mitigation candidate. Some of the high-level goals in this phase are to measure each threat against a prioritization framework or security bug bar, track each threat as a task or work item in a backlog, generate security control recommendations that are mapped to a threat modeling framework, and select one or more security control types and functions to address the threat. This slide demonstrates how we can identify stride threats within a data flow diagram. Ensuring we map an accurate framework with what's already generated can help us understand and tease out threat vectors. I generally refer to this image quite frequently when I'm generating my threat models. Now, last but not least is phase 5, to continuously iterate and verify. This verify phase is the last step of the threat modeling process, which often happens before the system is deployed. It involves ensuring requirements are met, assumptions are validated, and security controls are in place. Some of the high-level goals when reaching this stage are to confirm all previous and new security requirements are satisfied for the system, configure cloud providers, operating systems, and components to meet security requirements, ensure all issues are addressed with the right security controls, take system through manual and automated verification before deployment. Now that we understand the basic fundamentals of creating threat models, let's jump into a fun exercise where we can threat model the Death Star. Now, let's follow through the phases of the algorithm that we discussed earlier and apply them to understanding the Death Star. So according to the US government, the US government, the first Death Star would have cost $852 quadrillion to construct. The Death Star took 20 years to build because of its sheer size and complexity. The Death Star is a very complex piece of machinery which contains very intricate services which rely on each other to achieve total destruction and induce fear throughout the galaxy. The Death Star's main purpose is to function as a mobile platform for its main weapon, the super laser. The Death Star's structure is basically an enormous housing for the super laser and reactor that powers it. At a high level, the Death Star is made out of 4 major components: the battle station, the super laser, the propulsion system, and the hypermatter reactor that powers it all. Now let's look at these components in depth. The first thing is the battle station. It's a huge equilateral trench that splits the surface of the station into 2 hemispheres. This trench is used to house many of the Death Star's main systems, which includes the landing base, the drive thrusters, the sensor arrays, a tractor beam system, and thermal exhaust ports, which were an outlet for dissipating the excess heat produced by the large energy reactors used on the starships and space stations within certain ground structures. The super laser. It has a massive lens built around a huge synthetic focusing crystal. The lens is known as the eye and is surrounded by 8 tributary lasers. The Death Star super laser derives power directly from the hypermatter reactor, and the laser converts the focused full power of the reactor to create the beams. The propulsion system is the Death Star's real space propulsion system, made up of a network of ion engines that uses converters to transform reactor power into thrust. The engine thrusters are primarily lined along the equator of the station. And last but not least, the hypermatter reactor. The greatest challenge in designing the Death Star was not creating a big cannon big enough to fire a beam that could destroy a planet, nor was it creating a battle station the size of a small moon. The greatest challenge was always powering a cannon that big enough to fire a beam that could destroy a planet and moving a battle station that is the size of a small moon. The answer to both of these problems was solved with the invention of the hypermatter reactor. Now we have decided to create a data flow diagram to best represent some of the threats from analyzing the existing system. As you can see here, the image might be a little small. However, there is one main supercomputer that can be interacted with throughout the Death Star system. That supercomputer can align the laser, it can activate the hyperdrive, it could create some of those shields around the Death Star, And there's also tons of little miscellaneous things that it also does, including, regulating the sensor arrays, activating the drive thrusters, and so on and so forth. So this is an actual threat modeling diagram that I created in Visio. I've seen lots of threat models get created in lots of different tools. However, Visio is the threat modeling tool of choice for me. Some of them auto-generate you out some threats and reports. However, in my opinion, it's more fun to step through this exercise manually, because then you'll have a better understanding of your system at hand, and some of those auto-generated threats can be a little misleading. All right, now that we have created our data flow diagram, let's use a framework. In this case, I like to use Stride, not just because I'm a Microsoft engineer, but because I think that Stride does a really excellent job on helping you identify some of those threats. All right, so here we can see our threat actor on the outside looking in. And I like to draw these little maps because they're really just high-level representations of attack trees. And each of these spawns of this attack tree states the goal node on what the adversary is trying to achieve. So here in this example, the adversary is trying to achieve mind control access over one of the commanders that are trying to access the computer, which that would really only be reserved for Jedi. So not everyone can actually exploit the system in this way. However, there are things that we can do, such as jamming the signal array, try to access that supercomputer. Also, when we get access to that supercomputer, we can deactivate the shields, we can reposition the ion cannons, and there's tons of other threats that can be associated with what we see here in this diagram. But for now, I'm just going to state a few. Now let's jump into the brainstorming mitigation strategies for the identified threats from the previous section. So before we get into it, let's do a little bit of defining here. So a vulnerability is any weakness, known or unknown, in a system, process, or other entity that could lead to its security being compromised by a threat. In this case, the vulnerability will be the thermal exhaust port, and this is an act of exploitation. An exploit means to take advantage of a vulnerability. In this example, Luke Skywalker exploiting the thermal exhaust vent by launching torpedoes into the vent, impacting the core and triggering a catastrophic explosion comes to mind. Now, the mitigation against this could be to eliminate the 2-meter wide thermal exhaust port or safeguard this exhaust vent with extra defenses and perimeters. Now let's get into the crux of the Stride threats. So S, as we remember, stands for spoofing. This threat is a property of authentication, where the definition is spoofing involves an adversary creating an exploitation confusing about who is talking to who. In this example, impersonating stormtroopers to hijack communication systems and save princesses is done by Han Solo and Luke Skywalker. However, if you historically watch any kind of Star Wars media, you'll see that a lot of people in these movies do impersonate stormtroopers. So what could possibly be the mitigation against this? We could authenticate the principals, which are users and machines, by enabling more robust and multiple identity mechanisms, such as MFA, to actually say and verify who you are. Now T stands for tampering, which is a property of integrity. Tampering involves an adversary modifying data, usually as it flows across a network, in memory, on disk, or in databases. In this example, Obi-Wan Kenobi is tampering with the tractor beam system to allow the Millennium Falcon to fly into the sunset. The mitigation here could be adding validation such as credential codes and safeguarding by including cameras, guards, and limited access around the machinery. Now this threat repudiation is a property of non-repudiation, where the definition is repudiation threats involve an adversary denying that something happened or claiming to not have performed an action. In this example, Han Solo saying there's a very dangerous reactor meltdown in an attempt to staging a divergence to save the princess. The mitigation here could be to ensuring a proper observability is in place to track down adversarial behaviors and those logging behaviors so that we can ensure that these are actually true acts. I stands for information disclosure. This is a property of confidentiality. It's exposing information to someone not authorized to see it. In this example, Jyn Erso is relaying critical Death Star vulnerability information to the Rebel Alliance. And the mitigation here could be a thorough understanding of your asset inventory and public exposure, also highly important to help with mitigation for a threat like this. Now, the next threat involves denial of service, which is a property of availability. So this is to deny or degrade services to users. In this example, Chewie is jamming transmission channels for a TIE fighter, and the mitigation could include ensuring communication channels are encrypted and only verified users can access those channels, as well as practicing redundancy, such as a backup channel to be available whenever a channel goes down. And last but not least, our favorite, privilege escalation, which is a property of authorization. The definition includes elevation of privileging threats involves an adversary being able to do something or obtain the rights to do things which they don't have access or authorization to do so. In our example, R2-D2 hacking into the Death Star system to open doors and extract information. That is how R2-D2, he does it a lot. A lot of droids do it in the Star Wars universe. They seem to just be able to plug in and get any kind of information they need, the map of the whole system, and it can open doors. Now, a mitigation against this can be to put checks in place to verify appropriate access levels with each request. And last but not least, we want to continuously iterate your threat models. Sometimes a small opening is all that is needed to cause great destruction. Thank you everyone so much for listening to my talk. Here are some great learning materials. So Microsoft does have a secure development lifecycle Microsoft Learn module out there where you can go out and figure out how to create threat models on your own. It even has a small introduction to this threat modeling tool that gets used sometimes throughout generation of creating those threat models. For the tool, I would definitely take it with a grain of salt. It's really there to help you understand some of the threats that it is outputting. It's not super up to date, so I would not expect that to be something that you can just spit out and completely use on any of your projects, putting that out there. Also, there's some great learning that you can, get from the web about OWASP Top 10 as well as other OWASP threat modeling tactics. Thank you guys so much. May the force be with you, and I do hope that this talk was informational for you. Thank you so much. If you have any questions, please feel free to add me on LinkedIn. You can just go to linkedin.com/aulong. That's AULONG. And I would be more than happy to answer any questions that you may have. Thank you everybody so much.